All right, so on page 7, we're taking a look at just a few definitions here to review, and then we've got our 2 by hand problems and then 1 in the calculator. So what we need to remember is that distance traveled is a scalar. Can someone tell me what that means? Scalar. Okay, just magnitude, right? Okay, there's no direction. Okay, it is a real number, all right? And then these are basically how you find them. Displacement, you're integrating velocity. Distance traveled, you're integrating speed. Wait a minute. I thought we were integrating velocity. What does it say speed? Speed is the absolute value of velocity, okay, over the given time interval. This is important because all this has to do with your velocity function. So you need to know these. Okay? All right, so we're given this problem that says that a particle moves with a velocity of t squared minus 2t over the given time interval. So my first question to you is, if I asked you to graph the velocity function, what would it look like? It's a parabola, t squared, right? Okay, so what we want to do is find the displacement. Well, this is actually kind of easy. Why? How do we find displacement? Integrate your velocity. So you don't have to worry about where it's negative, true? Okay, and they want us to integrate from 0 to 3. So we're going to integrate our velocity function from 0 to 3 of t squared minus 2t dt. Okay, what is the integral of t squared? 1/3 t cubed minus, what's the integral of 2t? Yeah, this is minus t squared, and we're evaluating from 0 to 3. Why did I not put a c on there?
Because it's definite.
Yeah, because it's a definite integral. Okay, yes, it is defined. Okay, so this is, how do I evaluate this? What do I use? I don't really ask you.
The reversal spell method.
How about in mathematical terms? Okay, instead of Harry Potter. No. Fundamental theorem of calculus, part 1, f of b minus f of a. Okay. You said it so quiet. With confidence. Yes, FTC, number 1, right? Okay, so this is f of b minus f of a. So literally, and I'm just going to do it all out. I know you can do some of this stuff in your head. But 3 cubed is 27 times 1/3 is 9. Minus 3 squared is 9. So this is f of b, meaning your upper bound. Minus, when your lower bound is 0 and these are all variables, what happens? Yeah, it just goes away. So this is minus 0. I just wanted to show all the work. Okay, so in this case, we're saying that displacement is 0. Can someone tell me what that means? Yes, sir?
It stopped and ended at the same point.
It started and ended at the same point. Okay, so then what is another way of framing, or how would I say the integral? What does it mean? Don't say the antiderivative, please, because it's the same thing. How did we start with the integral? What did we do? We were finding the area under the curve. So what does that mean if the area under the curve is 0? Yeah, I've got the same amount of area below the x-axis as I do above the x-axis. Do you guys understand what I'm saying? Yeah. So if I asked you to graph this and you were sketching a graph and you already knew the displacement, we're going to sketch a quick graph here, just like this. Okay, so we're saying that we want to go from 0 to 3. Okay, it's just a sketch. Let's see, here's my velocity function. So this is t times t minus 2. Let's see. So if I chose at 0, 0, 0 is one part of my graph. Then if I plug in 2, this is also 0. And if I plug in 3, 3 minus 2 is, so this is 3. 1, 2, 3. All I did was pick some points. So we know that this is a parabola or a quadratic, right? A parabolic shape. So if I had to sketch it, wouldn't it go something like this? I don't know how far down it goes, but it goes something like this. And then this would be the end of my graph. Does that make sense? Now again, because I don't have all of the points, right now it doesn't look like this area, which is below the x-axis, based on the way I drew it, is the same as this. But even if I did draw it to scale, this would be more of a semicircle type shape, and this would be a triangular shape. It doesn't look like the area below and above would be the same, but based on our calculations, it needs to be. Does that make sense? Okay, so you might be asked to speculate what this means about the area under the curve. Do you understand what it means? Everybody okay? Yes, dear.
Why do we not use the table rather than the theorem? Wasn't the theorem a variable on the top?
That's fundamental theorem of calculus part 2.
The first one, you don't need a
no.
variable.
The fundamental theorem of calculus part 1 is a bounded region. 0 to 3, 1 to 7.
Why can't
Negative.
we use a table?
Why would you use a table?
Isn't when it's definite boundaries, we use the U table?
The table is for U sub when you change the bounds. If you're leaving U in and X, when you make a U sub. No. So just like the problem that you were helping with was 16 minus X squared, once you change those bounds to U, you didn't have to put the X back in. So you're combining 3 different things. So just be careful. Yeah, Adam, when you're done, can you do me a favor and turn off that fan? Thank you. Okay, here we want to find the distance traveled. So remember, distance traveled cannot be positive. So take a look here. Is there a portion? Did I say that wrong?
No.
Oh, okay.
Well.
Is there a portion of my function that is negative? Just look at the graph. Yes, from where to where? 0 to 2. Now, I know this because I'm looking at the graph. However, if I did not have the graph, I would take my velocity function, and the distance traveled is based on where v of t is equal to 0. So we're going to take v of t, and I'm actually going to factor this and set it equal to 0. So I have critical numbers where? 0 and 2. So that means I would have my number line. We're going from 0 technically to 3, so I'll just put 2 in here somewhere. Okay, and I want to figure out, you already told me from 0 to 2, my function is negative, so that means I would have to take the absolute value of that. Do you guys understand what I'm talking about? So if I didn't have the graph over here, and I had to figure this out, how would I do this? We've done this before.
That liney thing.
He's talking in all these technical terms. I'm not really sure what he's talking about. How do I figure out where my function is negative? Thank you, sir. How do I figure it out?
Plug in where?
Plug in 1. Plug in 1 where? Where am I plugging it in?
Into the velocity.
Yeah, into the velocity function. Thank you, Ben Franklin. 1 minus 2, so that means this is negative. Okay? And then 2 to 3, if I plugged in 2.5, yeah, it's positive. Okay, so why did I do this? The reason why we did this is we needed to determine, if we did not have the graph, where we have to negate our function. So you have to split up your intervals. So if I had another interval that was negative, I would have to break up that interval too, because I need to make this interval positive. I need to make all the values on there positive, because I'm looking for the distance traveled. Does everyone understand what I'm talking about? Okay. Yes, you do?
Question.
Okay. You have a question? Oh, okay. All right. So here I have the integral from 0 to 2 of t squared minus 2t dt. And I need to negate this because it's basically taking the absolute value. That's what you're doing. Okay. And then I have plus this integral right here, this interval from 2 to 3, but it's already positive, so I don't need to negate it. Otherwise, you're going to get an incorrect answer. So then it's going to be the integral from 2 to 3 of t squared minus 2t dt. Okay, before I move on, does everybody understand why we split this up? It's for the distance traveled. Now, the good news is we already did some of the work. We already integrated, so now we just need to evaluate. So this is going to be the opposite of 1/3 t cubed minus t squared to be evaluated from 0 to 2, plus then we've got 1/3 t cubed minus t squared to be evaluated from 2 to 3. Okay, so we want to plug in 2. Do we have to plug in 0? No, because we already know what's going to happen, right? You're going to get 0. So when I plug in 2, this becomes, 8/3? So it's the opposite of 8/3 minus 2 squared is 4, so can I make this 12/3? Okay, so if I didn't have this negative, look at this area under the curve. Positive or negative? It's negative, so that matches the graph, right? Okay, so then here, the good news is we already evaluated at 3. Remember? It's on the other side. So this is 9 minus 9. That's this part. Okay? And then this is minus, when I plug in 2, we got 8/3 minus 12/3. So we already did a lot of the work in the beginning. Okay, before I continue, does everyone understand where all these numbers came from? I didn't just like make them up. Okay, so this actually becomes positive 4/3 plus, this is 0, this is negative 4/3, and we're subtracting, so it's 4/3. So the distance traveled is 8/3 units, whatever it is. Okay, questions before I go to the next problem? Everybody doing okay? All right, so there's a couple of pieces in the next problem that you need to make sure you understand. And for those of us that either have not taken physics or don't pay attention in physics or whatever you're doing in physics, I don't know, you need to make sure you understand, because if you ask me during the test, I can't tell you. So here we're given our acceleration function, and it says that a of t is equal to the sine of t. Then we have some notation right next to it. Can someone tell me what this means? Okay. Initial velocity, okay? What does that mean? Oh, it's the starting point. So that means at 0, the velocity is 1. Yes? So this really means I have v of 0 is equal to 1. All right, and then we have our time interval, okay, from pi over 4 to pi over 2. Okay. Everybody all right? So if we want to find displacement, we have to have which function? We have acceleration. We need, do we need the position function? How do we find displacement? Go to the top of your page. It tells you. We need the velocity function. So I have to integrate once, and that's why I need that point on the velocity graph so I can find the constant value. Everybody good? Okay. So the first thing we need to do is integrate the sine of t dt. Okay. What is the integral of the sine of t? Yeah, it's negative cosine of t plus c. All right, now I need to find the c value. So we have v of 0 is equal to negative cosine of 0 plus c, and we're saying that that's equal to 1. What's cosine of 0? 1. The opposite of 1 is negative 1. You add it. What is your c value?
2.
It is 2. So that means my velocity function is negative cosine of t plus 2. This is important. Okay, so to find displacement from pi over 4 to pi over 2, do I have to split up the interval? Do I need to do anything crazy, or do I just integrate? Just integrate. All right, so we have the integral from pi over 4 to pi over 2 of negative cosine of t plus 2 dt. Okay, what is the integral of the negative cosine of t? It's negative sine of t. Okay, negative sine of t plus, is this 2t? To be evaluated from pi over 4 to pi over 2. Okay, up to this point, is everybody okay? All right, now we're just dealing with f of b minus f of a, right? Okay, now here's the deal. This is non-calculator. So you might not get an exact 1.2378, whatever the decimal, you don't know. You simplify as much as you can and you stop. Okay, so we're going to plug in. We've got f of b, so this portion is going to be negative sine of pi over 2 plus 2 times pi over 2 is pi. Then this is minus negative sine of pi over 4 plus this is pi over 2. Okay, can we evaluate the sine of pi over 2? It is 1. So more specifically, in this case, won't this be negative 1? Negative 1 plus pi. This becomes what? Yeah, square root of 2 over 2. So this is negative, but minus a negative becomes positive square root of 2 over 2. And then this is what? Minus pi over 2. So I could combine these pi terms, right? But other than that, I've got negative 1 plus the square root of 2 over 2 plus pi over 2. Okay, whatever that value is, which I actually know the decimal, that's all I've got. I can't do anything else. I don't have a calculator. Everybody good so far?
Where would the pi go?
Pi minus pi over 2.
Oh, okay.
It's like 1 minus 1/2.
Okay.
Everybody good? Okay. So now we want to find the distance traveled. And in order to do that, I actually need to set my velocity function equal to 0. How do I know that? Because I set it up here. It's right there. Okay. So if I literally do that and I set negative cosine of t plus 2 equal to 0, I want to know where the cosine of cosine of t is equal to 2. Okay, question. If I ask you for any, like the cosine of pi over 2, cosine of pi over 6, where are you getting these values? Where do you get the answer? Okay, what's that called?
We set it up.
Was that backwards? Oh, okay. Unit circle. All right. Sure, I'll take that interpretation. Unit circle. Unit circle. What is that? Why is it called a unit circle?
It's a unit. I think it's huge.
I think she's gone.
Is the unit circle really large? What is the radius? Oh, 1. So is there relatively speaking, is there any angle that you would take the cosine of and get 2? Why? We just talked about it. What's the radius? Oh, okay, so I can't solve this. Does everyone understand why? Okay, now think about it like this. Remember in Algebra 2 when you guys would do the transformations of, let's say, a parabola, because that's the easiest one to remember. If you had a negative on the outside, what does that tell you about the graph? What happens? Okay, so it flips over. It's a reflection. So if you think about your cosine graph, literally your cosine graph looks like a smiley face, right? Okay, so then if I flip it upside down, now you have this frown. Okay, and then what does the plus 2 do? Plus 2. Yeah, it takes the graph and moves it up 2 units. Do you guys understand what I'm saying? So now what happens is, if you had your graph, okay, let's see if I can do this. So if this was 1, isn't it max, base, min, base, max, like this? This would be the original. So then if you flip it over, it goes like this. It goes down here, 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 here. So then you're up like this. But then you just told me that this whole thing moves up to 1, 2. Right? Yeah, 1, 2. So then my baseline is here, so that means it goes like this. Let's see if I can get this right. This, this, this. Something like this. It's up. So here's my question. Is there any portion of this graph now that's going to be negative? No. Okay, so this is where it's important that you kind of know what's going on with the graph. So you have this portion under the graph, and this is from pi over 4 to pi over 2. I'm just kind of estimating because I didn't draw a scale on there. But this right here is going to be the area or the distance traveled. So now I don't have to worry because the distance traveled is going to be the same value as the displacement. And literally this is positive. So I did find out what the decimal was. It's 1.2779. Okay, so you need to sometimes think about what's happening with this graph. So here, the velocity, excuse me, that's wrong. The distance traveled is equal to the displacement because the velocity graph is always positive. And the reason why is this is just going to approach. Okay, Okay, and it's going to basically go back up and go back down and go back up and go back down. So it's above the x-axis, so it's never going to be negative. So that means the distance traveled, this right here is also equal to the distance traveled. Now, does this happen a lot? No, but this actually makes you think. So we gave you an example. You have to think about it. So my suggestion is at some point make sure you go back and just take a look at it and make sure you understand. If you don't, you need to ask. Okay, questions on finding displacement versus distance. They're both based on velocity. Okay, and it's important that you understand the difference between the two and why you have to negate one versus the other. Everybody okay? All right, so let's take a look at this next one. Here we have the scenario where the velocity of a mouse running alongside a baseboard is given by the following function. So they give us the velocity function. Okay, and they give us the time interval from 0 to 6 where t is in seconds and your velocity is in meters per second. And what they want is for us to estimate the time or times at which the mouse is 2 meters from its starting position. So I have the velocity function. What do they want?
Position.
Okay, so we want the position function. Now, we're not trying to figure out the position of the mouse from time 0 to 6. What we're trying to figure out is at what time or times is this mouse 2 meters in either direction. So what does that mean?
Positive or negative.
Yeah, plus or minus, left or right, from where it started. Now, does it really matter where this mouse started? No. Okay, so what happens when a mouse gets scared? Anyone know?
It runs.
But does it just take off and runs in one direction, or does it freak out and dart all over the place?
It scatters.
Okay, so they sort of dart back and forth. So there is a possibility that this mouse could dart back and forth and be on the left or on the right more than one time in that time frame. I mean, mice are fast. They're hard to catch, you know, like spiders. Okay, so here's the deal. Neither one of those is my favorite. So if this is my velocity, let's see if we can integrate 3 over t squared plus 1 minus 1/2 t dt. We will use a calculator eventually, but I just want to see what's happening here. First of all, there's a 3 on the top, but what does this look like? Inverse tangent. Okay, so we're saying 3 inverse tangent of t minus, can you integrate 1/2 t? Well, what's the integral of t?
Oh, yeah. Sorry.
Oh, it doesn't matter. It's fine. What's the integral of t? 1/2 t squared, so 1/2 times 1/2, this would be minus 1/4 t squared. Now, because we have a time frame, I don't need to write plus c, but what we're looking at is this is the position of this mouse, right? And we want to know when this mouse is 2 meters to the right and 2 meters to the left of where this mouse first started, meaning its starting position. Okay, in the time frame from 0 to 6. So what you can do is literally put this in y sub 1, and we're going to start with the positive, but we're going to put this in y sub 2. And then if you wanted to, you could even put that in y sub 3. It doesn't matter. But I'm going to show you what we're going to do. So let's go into y equals and put our function in. I'm just doing the first two. And once I type this in, okay, this is what I've got. Here's my first function, and I just typed it in as a decimal, 0.25. And then here is 2 meters to the right. I need to change my window. Why? Are they looking? Right now my window is negative 10 to positive 10. First of all, x represents your time. Can I have negative time? No, because what's the time frame? I heard it louder. 0 to 6. So 0, can I put, I don't know, just say 7, just to make sure I get 6 in there? Okay. Do I know what I need to do for my y min? Y max. Do I have a clue?
Nope.
Yeah, you could do that. Okay. If your function's not graphing, check your mode. If you're in degree mode, it's not going to graph because it's a tangent function. Okay. Right now, I left that from negative 10 to positive 10. It's too squished. Do you agree? I can't see. So I'm going to go back into my window and I'm going to change this. Adam said maybe 2. So maybe, can I make this, I don't know, let's just say negative 5 to positive 5, just so it's open enough so that I can see, but still wide enough. Okay, so again, here is, what's that a graph of? What just graph? Not that one, the one before. What did I put in Y sub 1? The position function. Okay, so that represents the position of the mouse, true? Now we're looking at time interval from 0 to 6. And we are looking to see where this, or when, not where, when this mouse is 2 meters to the right. This actually happens twice because mice are skittish, right? They freak out and move all over the place. So we need to calculate this. So how do I calculate?
Trace it.
Or more specifically, if I want the exact, I want to calculate the point of intersection, option 5. So I'm just going to go enter, enter, enter. So it's going to calculate this one first. So at time 2.5099 seconds, the mouse is 2 meters to the right. I have an echo. Okay, so t equals 2.5099 seconds. Okay, I need to calculate the other one. Second trace, option 5. Just going to get closer to the other side. Enter, enter, enter. And at 0.9033. Okay, so here's my question. How do I figure it out when the mouse is 2 meters to the left? Yeah, go into y equals and change this to negative 2. Okay, this only happens once. So someone do me a favor and tell me what that time is. 4.945, I think it's 2, right? So then t is equal to 4.9452 seconds. Whoops, the mouse is 2 meters to the left. Okay. Questions on how you do those calculations?